Welcome guys, in this video I will be solving this question from the chapter named Thermodynamics of Physics. Okay, the question says 1 mole of an ideal gas undergoes a process as shown in the following PV cycle, this cycle, okay, where the cycle follows the path 5 to 1, this one 5 to 1 and then 1 to 2 and then 2 to 3 and then 3 to 4 and then 4 to 1. Okay, and they have given here that the entire cycle is carried out with this air using adiabatic constant of 1.5, gamma given to be 1.5. okay, and the compression factor K is defined as the ratio of largest and smallest volume in the process for this process. Okay, so basically what they are trying to say is that K is equal to 10 and they have given that already it's a ratio of largest and smallest volumes. Okay, here if you see the x coordinate corresponds to volume. Okay, now here the largest volume is V1 and V4 and here the smallest volume is V2 and V3. If you take V1, the corresponding smallest volume will be V2. If you take V4 and the corresponding smallest volume will be V3. Okay, this is the concept. Now V1 by V2 equal to V4 by V3. This is the data that we can extract from this question. Okay, and now let efficiency eta denote the efficiency of the cycle, T1 and T2, T3, T4 denote the temperatures at point. So let's write T3, T4, T1, T2. Okay, at points. Then the following options are, all these options could be verified and then only it is said that it is correct or wrong. So let's start with the process 3 to 2. Okay, they have given that 3 to 2. Look at here V2 equal to V3, which means it is an isochoric process. Since this one is isochoric process, the work done P into change in volume is 0 because there is no change in volume. V2 equal to V3. Okay. Now, as per first law of thermodynamics plot, dq is equal to du plus dw. Since work done is 0, the change in work done will also be 0. Now, dq is equal to du. And I know the formula that dq is equal to du is equal to n du formula, internal energy NCV delta T. Here the corresponding temperature difference is that the process is going from 2 to 3. The final temperature is T3 and the initial temperature is T2. Now N CV T3 minus T2. Whereas here the heat is given to the system. Here the heat Q1 is given to the system, so it must be positive. So therefore Q1 is equal to NCV T3 minus T2. Now let's find the value of Q2. Since Q2 is given out by the system, if the heat energy given out, it will be negative according to law of thermodynamics and sign convention. Okay, and CV, since the process is from 4 to 1, let's take T1 minus T4, and I want to take negative sign inside, so N CV T4 minus T1, and this is the value of Q2. And then let's take the overall entire cyclic process. Okay, and let's apply first law of thermodynamics. Okay, delta Q delta U plus delta W, and this is the formula for physics. And for chemistry we have a different formula, so this is the formula that should be used by solving physics problems. Okay, and we all know that delta U is 0 for a cyclic process. Delta U is always 0 for a cyclic process. So let's get rid of this term. Delta Q is equal to delta W, and if you look at this diagram closely, we could say that Q1 is the heat given to the system and Q2 is the heat released by the system. So what will be the change in heat energy? What will be the change in heat energy? So delta Q is equal to Q1 minus Q2. that equal to work done by the cyclic work done in that cyclic process. So we have got that work done as Q1 minus Q2. Okay, so with the help of this formula we could verify option D, and we all know that efficiency eta is equal to work done in that particular cyclic process or by that engine divided by heat given to a particular cyclic process or the engine. Okay, this is the formula. Look at here. Here Q1 is the heat given to the system and Q2 is the heat released by the system. So we don't have any applications regarding this Q2, but we have applications regarding Q1 because the efficiency defines as it's the maximum work produced by the cycle or engine to the given amount of heat. So we require Q1, which is the heat given to the system, and Q2 is not required because heat is lost in the form of mechanical energy. Okay, now eta is equal to work done divided what is the heat given to the system, Q1, and we have found that Q1 W is equal to Q1 minus Q2 by Q1, and now 1 minus Q2 by Q1. We have got this answer. Now let's check the option D, and this is the wrong answer because we have got Q2 minus Q1. Okay, now let's check for option C. It is in the form of temperatures. Okay, so T1, T2 and T3, T4. Let's take the process of 3 to 4 and 1 to 2. In question they have given that this are all adiabatic process. Okay, since these are all adiabatic process, the change in heat energy or change in heat equal to delta Q equal to 0. Okay, now it should need to obey these three equations. T into V power gamma is equal to constant, T into V to the power gamma minus 1 equal to constant, and then T power gamma, T power 1 minus gamma is equal to constant. Okay, now let's say that we need temperature, we need to verify option C, which is T1 into T3 equal to T2 into T4, and they have given that this constant is another, so we no need to confuse with it. They have given that K is equal to 10, that equal to V1 by V2 equal to V4 by V3 in the question, and we have got this formula in this question. Okay, so let's apply with it. So we need this equation, this second equation, to find this relation is correct or not. So if I take T1, the corresponding volume will be V1, and if I take T2, the corresponding volume will be V2 to the power gamma minus 1 to the power gamma minus 1, and we know that gamma is equal to 1.5, so 1.5 minus 1, T1 by T2 is equal to V2 by V1 to the power gamma minus 1, which is V2 by V1 whole to the power 1 by 2. Okay, now V1 by V2 is equal to 10. It means V2 by V1 is equal to 1 by 10. So therefore, let's substitute it. T1 by T2 is equal to 1 by 10 to the power 1 by 2. Let's find the same relation for T3 and T4. T3 and the corresponding volume will be V3 to the power gamma minus 1 equal to T4, and the corresponding volume will be V4 to the power gamma minus 1. So T3 by T4 is equal to V4 by V3 to the power gamma minus 1, and we know that V4 by V3, here we have got the answer, V4 by V3 is equal to 10. So let's substitute here. T3 by T4 plus T3 by T4 is equal to 10 to the power 1 by 2, because gamma is equal to 1.5 and 1.5 minus 1 0.5, that is 1 by 2. Okay, now T1 is equal to T2 by root 10 and T3 is equal to T4 into root 10. Let's multiply these equations. T1 into T3 is equal to T4 into root 10 into T2 by root 10. Let's get rid of root 10 and we will be getting T1 into T3 is equal to T4 into 2 T2, which is the right answer. So option C is correct. We need to check now A and B. We know that eta is equal to 1 minus Q2 by Q1, that we have found before in the question. Okay, now 1 minus, and we also know that Q2, the value of Q2 is equal to N times CV times T4 minus T1, that we have found early in the question, and then Q1 value N times CV times T3 minus T2. Okay, now let's get rid of NCV, and 1 minus T4 minus T1 by T3 minus T2. So this is in the form of variable. Now I need to change this to a constant so that I can find the value of efficiency. Okay, so let's use this itself. T1 is equal to T2 by root 10 and T3 is equal to T4 into root 10. Okay, now 1 minus, I am changing T4 as T3 by root 10 with the help of equation 2, and I am keeping T1 as such. Okay, now T3 minus, I am going to change T2 as root 10 into T1 with the help of the equation 1. Okay, now 1 minus 1 by root 10 into T3 minus root 10 into T1 divided by T3 minus root 10 into T1. Okay, let's get rid of this. So 1 minus 1 by root 10. We will be getting the final answer as 0.68. Now, if you think that the B option is correct, you are wrong. The B option is wrong. Because here, if you multiply efficiency with 100, we will be getting by this answer 60% of efficiency, but by solving we will be getting 68% of efficiency. So there is a huge difference. So option B is a wrong answer. Now let's check for option A. No need to do further calculations. By using option B, we will check option A. Now I have solved this numerator and denominator to get this value 1 by root 10. So I can say that T4 minus T1 divided by T3 minus T2 equal to 1 by root 10. Or if you might have think that you don't understand it, you can compare this. Eta is equal to 1 minus T4 minus T1 by T3 minus T1, that equal to 1 minus 1 by root 10. We will get rid of 1 1 and minus minus. We will be getting the same answer. T4 minus T1 divided by T3 minus T2 is equal to 1 by root 10. So on plugging this in the calculator, T4 minus T1 by T3 minus T2 is equal to 0.32, and this is the correct answer. So option A is correct. We have got option A and option C. I might have think that you could understand this question. Thank you.